Hey guys, this is our second differential equations day. There probably will be a third one. I'm going to see how long these videos go and then decide what we're going to do next. But here's another kind of a problem. It's on 2 pages, so I'm going to have to switch back and forth a little bit here. But the question is, given these 4 differential equations and these 4 different slope fields, like, can you match a slope field and a differential equation? So remember that these slope fields show you at every point that there's a little line what the derivative should be equal to at that point. So like, if I had to guess what these derivatives were here, I would say that like the derivative here is like positive and maybe it's like a half or maybe it's like 2 or 3 or something. And here it's like -2 or 3 or something like that. Maybe it's -1 right there. It's like -1, but you can't really tell exactly what it is, but you can tell if it's positive or negative. And so it's like maybe not so obvious. You're like, well, how do I tell like when, like, how do I match these things up? One way to do it is to think about what y would be equal to if you took the integral of both sides, but you don't have to do it that way. I would do it like this. I look at this graph and I'm like, I know that right here on the x-axis, this is where y equals 0. And the derivative is clearly 0 there. So when y is 0, the derivative should be 0. That's not true for number 2. It's not true for number 3. But it looks like it's true for both 1 and 2. Like if I plug 0 in for y, I get 0 here and 0 here. So if I look at the other ones, it looks like 1 and 4 are going to have to go with a and b, because and both of these slope fields, when y is 0, the derivative is also 0. And so the way that you determine which is you look for another point like that. Generally, I look for places where the derivative is either 0 or undefined. And here it looks like it's 0 at y equals 0 for both of these, which means it could, a could be 1 or 4 and b could be 1 or 4. And to determine which is which, you find another place like that. So if you look at the slopes here in b, it looks like they're heading towards 0 right here as well. Like right there, it looks like the slopes are 0. Let me draw that a little less messy. Like if I drew a line, a horizontal line right here, looks like the slopes are approaching 0 there as well. So this is the place, if you look at the y coordinate there, this is the place where y is 2 also, where y is 2. And so which of these, if I look at the formula for 1 and the formula for 4, I'm like, which of these is equal to 0 when y is equal to 2 also? So if I look when y is 2 in this one, the derivative is -4, which is not 0. So this one 4 cannot be b. Now if I look at this one, when y is 2, the derivative is also 0, because I do 2 minus 2 is 0. So this one has to go, b has to go with this one, and a has to go with this one. And then I got to figure out for 2 and 3, which one of these is 2 and which one is 3. There's a couple ways to do it, but to me, I see this down here, that y on the bottom. And or I could do the x on top either way. Let's do x on top. So the x on top, that tells me that if x is 0, then the derivative should also be 0. So I go look at my other 2 pictures and I say, which one has a, when x is 0, that's like the y-axis, right? All the places on the y-axis are where x is 0. So I go look on my other 2 pictures, C and D, and I figure out which one has a bunch of little 0 slopes along the y-axis, and that is C, right? That's like, I'm looking at like these little slope lines. This y-axis is the place where when y equals 0. Nope. Where x is 0. And it appears that the derivative is equal to 0 there. And that's true for number 3, which means 3 has to match up with C, and which means 2 has to match up with D. So basically, when you're trying to match slope fields and differential equations, you look for places where the derivative is 0 or the derivative is undefined, and then you match it up with the one that happens at that place. So like I said, you just kind of match up the zeros here, match up where y equals 0, and the zeros here match up where y equals 2. The zeros here match up where x is 0. So you can really start with either the slope fields or the differential equations and just see which one is the most helpful. This is a little bit, this is like, there's kind of 2 other questions I can ask you about slope fields. I can ask you, I can ask you the matching question. I can ask you this question, which is, I give you a slope field and I say, sketch the particular solution given, sketch the particular solution if this is the initial condition. So what I would recommend you do if I ask you to do that is to write this as a point. The point would be 0, -1. And then go find that point on your graph. Looks like it's right here. X is 0, y is -1. And then you kind of sketch, you kind of like follow the slope field and you see like what it would look like. So looks like the slope is negative here. Oh, that's terrible. Slope is like negative, and then it's 0, and then it's like positive, and it goes like pretty much vertical by the end of it. Like these pictures don't have to be perfect, but they have to be like pretty good. So that this looks like it's like kind of paralleling these little slope lines. And this one is going to do like one of these numbers here. It looks like it's going to look like again, you try and draw these things so that they're relatively parallel to these things. It's like going to go like, this kind of gives you a feel for the shape of the picture. But you kind of have to like sketch in these curves, and you got to make them as close to parallel to each line as you can. So that's another question I can ask you. I can give you a slope field and a point and ask you to sketch the curve that it would look like. And the last question is this, which is where I can give you a differential equation and I can give you a certain number of points, and I ask you to just sketch what the slope field would look like. And so basically what you do is you just make like a list of the points that you have, and then you plug them in, the x and the y here, and it gives you, and then you kind of sketch the slopes. So let's see here. Maybe I'll start here. That's -1, -1, 2 is a point. -1, 1 is a point. -1, -1 is a point. And then I got 0, 2, 0, 1, and 0, -1. Zero, -1, and then I also have 1, 2, 1, 1, and 1, -1. And the question is, for each of these points, what is the slope of this curve going to be equal to? And the slope is given by this expression, 3x over y. So if I do 3x over y for this one, 3 times -1 over 2 is -3 over 2. If I plug a -1 in for each, I get -3. Oh, sorry, it's a -1 and a +1, so that's -3. If I plug a -1 in for each, I get +3. When x is 0, the slope is going to be 0. So all 3 of these are 0. That's convenient. And then I plug a 1 in for x and a 3 in for y, and I get +3/2. I plug in a 1 for each one, and I get +3. 1 for x, this will be -3. So these are the opposites of each other. That's convenient. Then you might be like, well, how do I draw a slope that's exactly 3/2? And the answer is you don't have to. You just have to make sure that the slopes are correct relative to each other. So for example, the zeros should all be horizontal. 0, 2 is horizontal, 0, 1 is horizontal, and 0, -1 is horizontal. These should all be horizontal, as you can draw. And then you just want to make sure that like a slope of 3 is steeper than a slope of 3/2. So just make sure that the 3/2 one is not as steep as this. So at 1, 1, it should be pretty steep. Like that, maybe like a slope of 3, and then 3/2 should just be like less steep than that. Doesn't have to be exactly 3/2. That looks a lot more like 1 than 3/2 to me, but as long as it's not as steep as this one, you're in good shape. So if 1, 1 is +3, then 1, -1 should be -3. And whatever this one is, just draw it like the opposite, like the same, about the same slope, but going down. And then we're going to do all these are going to be all opposites of the previous ones. So -3 should be like this. Again, it doesn't have to be exactly -3, just like this one's not exactly -3/2, but this one's steeper than that one. And that's what's important. This one should be +3. So there's not going to be like a lot of fine differences you have to draw. There won't be like a slope of 1 and a slope of 2 and a slope of 3. There'll be like zeros and then maybe 2 different ones that aren't 0. And that's it. Sketched. Done. So I do want to talk about this just because it's like, it was, we did this problem in the other, in the previous videos. I wanted to make sure that I showed you guys how to do this. I think I might have done this one. I'll just do it again real quick. This question here, it says a slope field is given for a slope field for the given differential equation. That's this one up here, is shown below. Sketch the solution curve that passes through the point 0,2 and sketch the solution curve that passes through the point 1,0. So they even mark those points on here for you so you don't get confused. And you just do the same thing we did here, which is where you try and sketch it in so that it kind of matches the indicated curve. Like that, maybe. This thing goes down to here, maybe, and it kind of does one of these numbers. And these should be relatively symmetrical if you can make them that way. The one that goes through 0,2 needs to be a little more exact. Like all of these lines are clearly horizontal, and you can check when y is 2, the derivative should be 0 the whole time. So this solution curve needs to be like directly horizontal through all those little slope lines. But if a sketch like this would get you full credit on this problem, both from me and from the College Board. And it's like pretty close. These aren't exactly parallel, but they're pretty close. And that's like what they're looking for. The idea is, do you understand the point of a slope field and what it actually is indicating? So those are the 3 questions I can ask you about slope fields. In the next video, I'm going to talk a little bit about a couple different differential equations and this idea about exponential growth and how differential equations help us with that. So stay tuned.